This video covers section 13.1, sequences, objective 2, find a formula for the nth term of a sequence. Finding a formula for the nth term of a sequence requires us to find the pattern in the numbers. The 3 to the 7 to the 11 to the 15. You first check if you're maybe adding the same number every step. Second thing to check would be, are you multiplying by the same number each step? Or the third thing to check is maybe you've got squares or maybe you got cubes. And what I see in letter A is my pattern goes from 3 to 7, which I'm adding 4, and then 7 to 11 I'm adding 4, and 11 to 15 I'm adding 4. So that means that we have this slope of 4. Remember, y equals mx plus b. We're now using a sub n for y, and x, the variable, is now an n. So if the slope is 4, we would just need to know what the b would be. The b stands for y-intercept, which always corresponded to 0b. And so if this is the first term of 3, the 0th term would be found by subtracting 4 from it, and it's a -1. Therefore, that would mean the sequence would start at 0. If it started at 0, it would be a -1, giving us a sub n is 4n minus 1. Another way to do it would be to say that you know that a sub n is 4n plus some kind of number b. You could say that it goes through the point 1, 3, the first term is 3, which means that a sub 1 is 3. We could do 3 equals 4 times 1 plus b, telling us that b is 3 minus 4, or -1. Giving us a sub n is 4n minus 1. Letter B. 2, 4, 8, 16. 2 to 4, you're adding 2, but 4 to 8, you're adding 4. So it's not one of the ones like letter A. But if I look at B, again, I'm multiplying by 2 to get 4, multiplying by 2 times 4 to get 8, 2 times 8, 16. So we're multiplying by 2 each step. This is like an exponential function, b to the x, whose base is 2. Now, sometimes you can just get away with 2 to the n, and sometimes you can't. So you try something like this, and then you check that if n is equal to 1, we get 2, or a sub 1 is 2. And if I plug that in there, a1 is 2 to the first, which is 2. And so a sub n equals 2 to the n is the formula for the nth term of the sequence. Letter C, we start off at 1, and then we go to -8, and then to 27, and then to -64, and then to 125. I'm not adding the same number, and I'm not multiplying by a number. So then I start checking squares and cubes. And it looks to me like 1 is 1 cubed, 27's 3 cubed, 8 is 2 cubed, 64 is 4 cubed, and 125 is 5 cubed. So we've got some type of cubes going on there. First term cubed, the second term cubed, and so on. So we're going to use n cubed. And then we see the alternating sequence. Alternating sequences are always obtained by using either -1 to the nth or -1 to the n plus 1. So again, I remind you from the previous objective that if the first term and the if the first term and the third and the fifth are negative, then we use -1 to the nth. But if the second, fourth, and sixth are negative, then we use an n plus 1. So we have the second, fourth, and sixth negative. So if I use a -1 to the nth, and I try to check this, a to the first is going to be -1 to the first, which is -1 cubed, which is -1. It doesn't work. But when I change it to a plus 1, 1 plus 1 is 2, negative 1 squared is positive 1. So when the even terms are negative, you need a negative 1 to the n plus 1. If the odd terms are negative, then you need a negative 1 to the nth. Here's a practice problem for you to try. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had a chance to work this out, I'll work this out with you. 4 to 9 to 14 to 19. We're adding 5 there, adding 5 there, adding 5, adding 5. Adding 5 each step, which tells us it's going to be a sub n equals 5n. Plus some number. This number should be such that when I plug in n equal to 1, I get 4. So if a1 is 4, then 4 would be equal to 5 times 1, which is 5, plus some number b. 4 minus 5 is negative 1, so that's going to have to be a negative 1. Another way to find it is to remember from linear equations, mx plus b, the y-intercept is 0b. It would be the 0th term in the sequence if it existed. Instead of adding 5 each step, when you subtract 5, you get the 0th term as negative 1, or a sub n is 5n minus 1. Letter B, one thing is consistent throughout this problem is that the numerator is always 1. The denominator, 2, 4, 8, 16. 2 to the first, 2 squared, 2 cubed, 2 to the 4th. So that's a 2 to the n. Then it alternates its signs. Because the first term is negative and the second term is negative, third term is negative, the odd terms are all negative. So we use a negative 1 to the nth power to denote that the odd terms are negative. If the even terms were negative instead, it'd be negative 1 to the n plus 1. Now this will look better written as negative 1 to the nth divided by 2 to the nth. And practice 3C. One thing is consistent throughout that problem is that the numerator is always 1, but now the denominators, negative 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, we're taking 1 over the term squared. And now we're alternating the signs, having the odd terms negative, so we have to have a negative 1 to the nth, giving us negative 1 to the nth divided by n squared. And this concludes the video for section 13.1, Sequences, Objective 2. Find a formula for the nth term of a sequence.